The sketch shows part of the curve with the equation y equals f of x. Sketch the curve y equals modulus f of x. Sketch y equals f modulus x. Describe a sequence of two geometrical transformations that maps the graph of y equals f of x onto the graph of y equals a half f of x plus 1. The maximum point of the curve with the equation f of x has coordinates minus 110. Find the coordinates of the maximum point with equation y equals a half x plus 1. So let's have a look at this question then. Here's the summary of the question. So we'll sketch these two things first. And I've got the templates below with f of x there. So the first one is y equals f of x. Y equals modulus f of x, isn't it? That's the first thing we want to sketch. So any values have to be made into modulus values, don't they? These are negative, so we make them positive by flipping them like so. And this also negative line needs to come down like so the other side. So that's what we've got then for the modulus function. Just tidy it up. Now we want the f of modulus of x next. So y equals f modulus x. Okay, so when x is positive, all these values will remain the same. But when x is negative, if we put a minus 1 in, we'll get f of 1. So it'll be the value here. So this value is replicated here. So it's basically a reflection, isn't there? This occurs on the same side, reflected. So we just need to get rid of the curve on this side then, because these values don't occur. And then we can just draw the curve. It's the same this side as that. So, I think that was it. So it comes down to minus 1, goes through minus 3, and then back up to reflect the curve on the other side. It should have come a bit lower if we were fussy about there really, because it needs to reflect that curve because it's the same both sides. So that's part A and B then. And bear that thought in mind there. Describe the two geometrical transformations that maps this onto that. So if we have a curve y equals f of x, I'll just do a sketch of it. Suppose it's here and we've got a point here. Let's put A and f of A. Okay, so if we want to sketch, say, the first thing to do is fx plus 1, isn't it? So what value? If this were 1, let's just try 1, nice and easy. So 1, and we'll suppose we have an output of 2. Let's just suppose, just for illustrative purposes, e.g., just to illustrate it. Now fx plus 1, what value would I need to put in to get 1? I'd need to put in 0. So this value here happens at 0. And the output, when you put 0 in here, you get the output that you would have got at f of 1, which is 2. So that point moves back. So it's a translation, this part of transformation. So firstly, a translation. And the translation vector would be minus 1 in the x direction and nothing in the y, wouldn't it? So there's the translation. And then we need to think about half. So we go from here now, say, as illustrative purposes. And we're here, 0 at, say, 2. And then we go to a half. So we now go to half fx plus 1. And that would move the point down a half value, wouldn't it? So it's stretched by a factor of half. And it's stretched downwards towards this line here, so it's stretched vertically, so along the y-axis. There's a vertical stretching, isn't it, by a factor of half. It's actually shrunk, isn't it? Okay, so that's that then. Those are the two things that I mentioned there. So we can get rid of that example so that the values, so that there's no confusion, because they were just illustrative. So that's what we wanted then. Okay, that's the two transformations. So part D now. The maximum fx on is at minus 110. Find the coordinates of this max on this. So minus 110. What happens to that on the original curve? Well, on this curve here, okay, minus 110, it basically translates it back then. This was the original curve, so this value needs to happen. To get 10 and minus 1, you need to put an input here of minus 2. Yeah, minus 2. So the point is minus 2 on the first curve. That's the x value. And then the y value is shrunk by half, so that would be 5. Maps to. And minus 2, 5. X equals minus 2, y equals 5.